Hi, hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to look into how a specific RPC from controller service or controller plugin is called as soon as we try to create a volume request in our Kubernetes cluster. So in some of the previous videos in this playlist or in this series, we have discussed about a lot of things. For example, CSI specification, what are CSI sidecar containers, and how a CSI sidecar container can be deployed along with your CSI plugin so that it would transform the volume related requests in Kubernetes to CSI plugin specific request. So all those things have already been covered. I will link the playlist down in the description somewhere. In this particular video, we are actually going to look into how Create Volume plugin or Create Volume RPC from controller service is going to get called when we try to create a volume request in our Kubernetes cluster. And we are actually going to also implement this. So if we look into the CSI specification, we can see that this RPC will be called by Container Orchestrator to provision a new volume on behalf of a user. So if a user requests a particular storage volume in the Container Orchestrator, in that case, this particular RPC of CSI plugin is going to get called. Now, in case of Kubernetes, this particular RPC is going to get called by external provisioner, and that external provisioner is going to call this create volume RPC as soon as we create a persistent volume claim resource in Kubernetes. We have talked about all of these things. How do we deploy it on Kubernetes in previous video? So if you have not checked that out, I highly recommend you should check that out. So let's just go ahead and try to. So what I have done is this is the GitHub repo, or this is the repo that we had created in the last video. I'm just going to open it in my text editor, and after opening it in the text editor, let's just go ahead and try to, if we look into the controller.go source code, let's just go ahead and try to just log a message that create volume of the controller service was called, and let's make sure that this particular method is being called when we create a persistent volume claim resource in Kubernetes. So we also know that when we try to provision a volume in Kubernetes cluster, to specify how exactly that volume should be provisioned, we specify storage classes. Again, I have talked about this in one of the videos. I will link that down in the description. So to specify whether Kubernetes is going to use entry provisioner, or the provisioning is going to be happen by CSI plugin or CSI driver, and any other detail about the volume that we want to provision, we specify these things using a resource called storage class. So let's go ahead and try to create a storage class for this CSI plugin that we have been writing, so that when we try to create a volume, we can specify that storage class, and in that storage class we can specify that we want to use this particular CSI plugin, or Kubernetes can use this particular CSI plugin to provision the volume. So let's go ahead and try to look into a sample storage class manifest, and this is the storage class that we are going to use. So let's cd into manifests and then sc.yaml, and let's just go ahead and try to copy this. Provisioner is the most important thing. that we are going to specify, and we do not want allow volume expansion, we want volume binding mode. And we are going to, let's just save it and open it in the text editor here. So in storage class.yaml, we can specify the name to be bsos because we are calling this CSI plugin bsos, block storage on scale, and the provisioner is going to be the driver name that your identity plugin returns. So if we go and look into the plugin info, it returns driver.name, and we know that the driver name is, it's a const here. So let's go ahead and try to specify this in provisioner. Once we have specified the provisioner, we are going to specify, I think we are good. And now if we try to create a volume using this particular storage class, and the CSI plugin that we have developed is deployed on the cluster, CreateVolume method of the controller plugin should get triggered. So let's just go ahead and try to do that. So I'm going to deploy these things. So we are creating deployment, service account, storage class that we have just added, and we are also going to follow the logs from this pod that was created. So all containers and then F. If you see here, it says started provisioner controller, and now let's just go ahead and try to create a PVC that is going to use the storage class that we have just created. So to create the persistent volume claim, I'm going to copy this particular manifest. This is official Kubernetes documentation, so you can figure out these manifests that I'm using very easily. So let's go ahead and try to create another file called pvc.yaml, and in pvc.yaml we are going to specify storage class name. In our case, storage class name is bsos, and we are requesting storage 8 gigs. Volume mode is going to be file system, access mode read write once, and let's name it test volume, and we are good. Now let's go ahead and try to actually create this volume request to make sure that create volume method from controller service is actually being called. Okay, so I think we have made a mistake. We changed this code, but we have not actually deployed the updated code. So let's go ahead and try to do that. So I'm going to build the application once again, and once the binary has been built, I'm going to build the Docker image. So the binary has been built. I'm going to build the Docker image. So docker build -t, and let's see how we are specifying the image, and we are going to tag it 6, and then we are going to specify context. Once Docker image has been built, let's go ahead and try to push it, and once it is pushed, we are going to I'm going to call it again with change tag, because I forgot to change the tag here, and then I'm going to push it, and once it has been pushed, we are going to change the image that we are using in our controller plugin manifest. Again, if you are not familiar with this particular manifest, I have covered everything in the previous videos of this series. So the image has been pushed. Let's go ahead and try to apply everything again, and we should see this pod getting restarted. And once this pod is restarted, we are going to look into the logs for the new pod, and we are going to create the PVC manifest now. So if you see here, the persistent volume claim was created. So if we list all the PVCs, we can see that a test volume PVC was created and the status is pending. Now let's go ahead and try to look into the logs of our CSI plugin that is installed. So if you see here, it clearly says that create volume of the controller service was called. It simply means that as soon as a volume request was created in Kubernetes cluster, external provisioner was able to figure that out, and then external provisioner actually called or translated that request to respective CSI plugin request, that is create volume from controller service. Now if we want to go into a bit more detail, we can also discuss that Kubernetes actually sees the storage class that is specified in this PVC request, and then it looks for the provisioner, and by looking at the provisioner, Kubernetes figures out if entry provisioner is going to be used, or if Kubernetes is not able to, let's say, provision the volume. In that case, Kubernetes is just going to annotate that PVC with a specific annotation, and then CSI plugin is going to handle rest of the things. So now we know that create volume is getting called at least. Let's go ahead and try to implement this. So we can see here the create volume method is going to get called with the create volume request. And if we look into create volume request, these are the main fields that we get in the request that is coming to our controller plugin. First is name. This is the name that container orchestrator generates. In our case, Kubernetes is going to generate and then passing that to the controller plugin. And this is the name that that controller plugin can use to create the volume in the storage provider. And using this volume, controller plugin can also check if the same request is being made for the same volume, or let's say if the create volume request is being made again with the same request name or with the same volume name. In that case, we will not even have to provision the volume again. So this is the name using which we will have to make sure that the request is idempotent basically. Apart from name, we have capacity range. So if we talk about capacity range is the field in which we are going to get the volume or the storage amount that was requested in our PVC. So if we look into pvc.yaml, if you see here, this is the request that we have specified, and this is the request that we are going to get in capacity range. Now if you look into capacity range in a bit more detail, it has two main fields, required bytes and limit bytes. So it simply means that the required field that we have specified, that means that that is the minimum that is the minimum memory, that is the minimum resource that user is expecting. And if they are also specifying limit bytes in that case, it means that this is the maximum resource that the user is requesting. Again, you can read about this in more detail by the comments here. And it also says that if you see here, to specify the exact size, required bytes and limit bytes shall be set to the same value. But if you specify just required bytes, in that case, controller plugin or your CSI plugin is going to make sure that at least that amount of resource, that amount of memory was created, volume of that amount of memory was created. So this is where we get the requested amount. Now if we talk about volume capabilities, so let's go ahead and try to look into volume capabilities here. So if you see here, it has access mode and it also has access type. So using access mode, you can actually specify whether this particular volume can be mounted on multiple nodes, or if it can be mounted on multiple nodes, can applications write on this particular volume simultaneously from multiple nodes and things like that. So if we go ahead and try to look into the details, if you see here, these are all the values that are supported. So for example, access mode unknown, single node writer, it simply means that only single node, if you see here, it clearly says that can only be published once as read write on a single node. The other values are single node reader only, multi node reader only. I think this is self-explanatory. So if we go ahead and try to look into our pvc.yaml again, it simply, if you see here, this is where we are specifying the access mode, and this is the access mode that is going to get translated into the volume capacity, that capability that we are seeing here. It also has another field that is access type, and access type actually specifies whether this particular volume is going to be consumed as a block device, or it is actually going to be mounted as file system. So that is also being specified, if you see here, by volume mode. So these are the two fields that are going to be translated to volume capability in the create volume request. Now the other thing that I wanted to talk about in create volume request is volume content source. So volume content source is the field using which we can specify how do we want to populate data for this particular volume request that we have specified. So in some cases, if we already have a snapshot and we want to create a persistent volume claim, or we want to create a volume from that snapshot, in the data source we can specify the snapshot ID. So if we talk about a scenario where you have taken a Kubernetes native volume snapshot, and you want to create a volume out of that Kubernetes snapshot, in that case, while creating your PVC, you can specify the snapshot ID in the data source, and that is what is going to be translated. So if you specified data source here in the PVC, that data source is going to get translated into volume content resource. So most of the times it is going to be snapshot ID, because if we have a snapshot ID and we want to create a volume from that snapshot ID, we can create, or we can specify data source in PVC with the snapshot ID. So that is about volume content source. The other thing that I wanted to talk about is accessibility requirement. So again, if you read this particular comment, you would be able to understand most of the things. But for example, let's say if there are some requirements that this particular volume should be or is going to be accessed from this particular reason, let's say, in that case, to specify those things, if we specify those things in pvc.yaml, those things are going to get translated into accessibility requirements. Now, if we talk about in which particular scenario Container Orchestrator can specify topology related things. So if CSI plugin, because here is the thing, even if we try to request something, even if we try to specify some topology related fields here, but CSI plugin is not actually capable of doing those things, in that case there is no point of specifying those things here. So topology related requirements, the things that we are seeing here, accessibility requirements, should only be specified by user if the plugin is advertising this particular capability. Does that make sense? So again, we have talked about capabilities, etc. So if we look into this particular capability, so this is the capability that identity service can advertise. So if you just go ahead and try to search this, so if you see here, plugin capability can return, if you see here, controller service, and it can also specify if it supports volume accessibility constraints. And if it supports volume accessibility constraints, in that case, obviously users can specify, and CSI plugin would be able to handle that. So now that we have looked into how the request actually looks like, let's go ahead and try to see how we can actually create the volume. So first of all, let's just write down the things that we would want to do. So first of all, we will have to make sure that name is present. And once name is present, what we are going to do is we are going to make sure that uh, we are going to figure out how much resource, how much memory user has requested. So we are going to say extract required memory, and once that has been figured out, we will have to see if volume capabilities make sure volume capabilities have been specified. And if they have been specified, we will have to validate if this particular CSI plugin is even able to support those volume capabilities or not. So validate volume capabilities. We are not going to implement all of the things here because we cannot basically in this video. But yeah, if you think that you want to actually see how these things are implemented, you can obviously refer CSI plugin for DigitalOcean in their upstream repo. So once we have validated the volume capabilities, the other thing that we want to validate is volume content source. So check if volume content source is specified. And the other thing that we want to say is accessibility requirements. So handle accessibility requirements. Now, to make sure if the name is present or not, what we can do is if request.name is empty, in that case, what we want to do is we want to return nil, and we also want to return a specific error, and we can return the error using status dot error, and we are going to specify invalid arguments code. So codes dot invalid argument, and then we are going to specify the masses. So we are going to say create volume or create volume was or must be called with a request name. Now that we have validated the request name, let's go ahead and try to figure out the resource requirement that has been specified in pvc.yaml. So if you see here, 8 gigs have been specified. So to figure that out, request dot CapacityRange dot required bytes dot get required bytes. So this is size in bytes colon equals to this particular value. Now here is the thing: there are a lot of things that you can try to do here, because let's say, again, like any well-written software, you will have to make sure that we are not getting unwanted or unexpected values as storage value here. Because for example, it can also be 0, it can also be a negative value, right? Or it can even be, let's say, 10,000 gigs, right? So in that case, you'll have to make sure that, and obviously if I request 10,000 gigs, in that case, obviously there are chances that your provider or whoever is writing this plugin for a specific provider, they don't support that, right? So in that case, you'll have to make sure that this particular value is not or satisfies all those constraints. So make sure the value here is not less than or equals to 0. And once we have verified that, we will also have to make sure that required bytes is not more than limits. So like required bytes, we also have limit bytes. So we'll have to make sure that required bytes is not more than limit bytes and things like that. So you will have to make sure, you will have to validate all these things. I'm not going to do that because of time constraint obviously. But yeah, when you write a production ready code, in that case you must do that. Now, the other thing that we are going to validate is make sure volume capabilities have been specified. So if request dot volume capabilities is nil, or length of request dot volume capabilities equals to 0, in that case again we are going to return nil, and we are going to specify that argument is not valid, and we will have to specify that volume capabilities must be provided. So we are specifying volume capabilities here. So let's say that volume capabilities have not been specified. And once we have made sure that volume capabilities have been specified in the request, we will have to validate the volume capabilities. Again, we are not going to implement this, but the things that we are going to make sure is we will have to make sure that access mode that has been specified in the PVC. So make sure access mode that has been specified by the PVC is actually supported by storage provider. So in this particular case, we will have to see if the access mode that has been specified is supported by. So for example, let's say if access mode was read write many, in that case that means that volume can be written by multiple nodes. And if our provider does not support that, in that case we will have to specify that we do not support this access mode. So similarly, we will also have to make sure that volume mode that has been specified in the PVC is supported by us. When I say us, I mean storage provider, because we are writing this plugin. Now, once we have made that sure, if volume content source is specified, in that case, what we are going to do is, let's go ahead and try to create the request using which we are going to call the DigitalOcean API to actually create the volume. So create the request struct, and we are going to do this. So godo dot volume create request, and this godo is obviously a DigitalOcean Golang API, and this is going to be called volume request, and this is going to have just to remove these errors, I'm going to print them for now. So I'm going to call it create or volume request, and like I said, just to make sure that we don't have any compilation error, I'm going to print it here, and let's go ahead and try to build this. So go build, and we are going to get into this problem because we have not downloaded that particular library. And once we have let's go ahead and try to create this request. So okay, so evaluated but not used. If it builds successfully, in that case we would be able to specify the things. I'm just trying to get that go def thing working. Yeah, so that we can actually look into how that struct looks like. So we can specify the name, and the name is going to be the name that we got from the request. So it is going to be request.name, and then we are also going to specify a reason. And if you remember from the previous videos, we are taking a reason from to our application, and we have that reason initialized in the driver.reason. And the other thing that we can specify is size gigabytes. Now, after size gigabytes, if you see here, the size that we have is in bytes right now. To obviously make sure that we convert that size in bytes to gigabytes, what we are going to do is we are going to divide that by what? Let's go ahead and try to do this math. So 1 byte is equals to 1024 kilobyte, and 1 KB is equals to, sorry, 1 KB is equals to 1024 bytes. 1 MB is equals to 1024 kilobytes, and 1 GB is equals to 1024 gigabytes. So in this particular case, if we have to convert byte, hold on, one KB is equals to 1024 bytes, 1024 kilobytes equals to 1 megabyte, and 1024 megabyte equals to 1 GB. So if we have to convert from bytes to GB, in that case we'll have to multiply these three values and then divide bytes divided by these three values. So basically whatever bytes that we have, and divided by 1024 into 1024 into 1024. And once we have this, we can actually specify that here 1024 into 1024 into 1024. Either we can have this, there is not a problem, but obviously we can enhance this, we can improve this, and we are going to look into how DigitalOcean does this. So once we have the volume request created, if you see, we will also have to make sure, we'll also have to see if while creating the PVC we have specified the data source to be snapshot, and if snapshot is specified, in that case set the snapshot ID in the volume request. So we will have to do something like this. So volume request dot snapshot ID equals to request dot volume content source dot snapshot id. So this is what we will have to do. Again, I'm not doing this, but we will have to, you can do this if you want to handle that scenario. You will also have to make sure that this snapshot is actually present. And once you have done that, you can make sure that you can try to check other things as well, because you are developer, you are writing plugin for your storage provider, the storage provider that you work for, let's say, or you are responsible for. In that case, you can check other things as well. For example, let's say if this can user has, or let's say has not exceeded the limit, or let's say if this user can provision the requested amount, etc. So all these validations can be done by you in this particular phase, let's say. Now, again, for example, if you want to, let's say, handle the accessibility requirements, if someone has specified that the volume is going to be accessed from, let's say, this particular region, and you do not support that, in that case, you will have to specify that. So all those things can be handled here. So, for example, let's say if someone says that this volume is going to be accessed from a separate region, but you are running your driver in a separate region, in that case, obviously there are chances that you would not be able to provision the volume so that it can be consumed from another region. So you will have to handle those things here. And once you have done all these things, what we are going to do is we are going to actually call the DigitalOcean APIs with this particular request to actually provision the volume. But before doing that, we don't have the client, DigitalOcean client right now. So let's go ahead and try to do that. So in the driver struct, we are going to have a storage client, and storage client is, let's call it storage, and this is going to be of type guru.storage service. And using storage service, obviously, if you see here, we can create a volume. That is the reason we are specifying a type of that interface. While initializing the driver, if you see here, we are just returning name, endpoint, and reason. But now we will also have to specify, we will also have to initialize a client of that service. So let's go ahead and try to do that. So first of all, we will have to make sure that to initialize a client, we need a DigitalOcean token. So let's go ahead and try to look into the DigitalOcean API reference. So API reference DigitalOcean, and we are going to look into how we can call a create volume request. So create a new block storage volume, and this is how we can create that volume. So we are going to create the client first using godo.new from token, but to do that, we will have to first figure out the token. So let's go ahead and try to see if we have tokens set or not. If params.token is not specified, in that case we would want to return an error, and that is the reason we will have to return two values from this particular function, and we will have to handle that from the place where it's being called. So driver :error, and if error is not equals to nil, in that case fmt dot println error creating new instance of driver once we have done that, once we have made sure that token was specified, token is present, in that case what we are going to do is token must be specified. And once we know that token is present, we will have to create that client. So this is what we are going to do. Go to dot new from token, and we can pass params dot token here, and this is going to get us client, and then we can specify storage service to be client dot storage. So now if you see here, we have initialized the storage client that can be used to create the volume. But before doing that, let's make sure that we are passing token to new driver. Okay, now let's go ahead and try to look into the create volume method here. So once we have validated the accessibility requirements, actually call DigitalOcean API to create the volume, and we can do that using the storage client that we just initialized as part of driver struct. So d dot storage dot create volume, and create volume expects a context and the request, and this returns volume response and error. So volume response and error, and if error is not equals to nil, it simply means that there was a problem provisioning the volume by DigitalOcean. So we are again going to return nil and status dot error, and this time again you will have to choose the codes wisely. We are going to choose internal, and the message is going to be failed provisioning the volume. And once we have provisioned the volume, we will have to return with the response that we see here, that is create volume response. So let's go ahead and try to return it, create volume response, and we will have to specify volume, that is CSI dot volume, and we are specifying capacity bytes, and capacity bytes is size in bytes, and we will also have to specify volume ID, and this is volume dot ID, and we can also specify, if you see here, we can also specify content source, but only specify content source, but only in cases where it's specified in the PVC. We are not going to use response here. So I think this should work, and we will also have to specify accessible topology here, and we can specify this from where this volume is going to be used, but we are not going to specify that here, just to make the things very simple. So it looks like we were able to implement create volume, but now let's go ahead and try to look into if we are actually passing the token when we deploy this in Kubernetes. So if we look into controller plugin, we are just specifying hyphen endpoint, but apart from endpoint, we also expect token, and that is the token that gets passed to new driver here. So if we do not pass token from here, things are not going to work, and we should try to read token from a secret. So let's go ahead and try to create a secret, and that is the secret that we are going to use to specify the token as environment variable, and then eventually the argument. So I am going to create the token very quickly. kubectl create secret, generic a name of the token that is do-token from literal, and key is going to be access-token, and then value is going to be my DigitalOcean token. So okay, so we actually have created a secret in the default namespace called du-token, and we have basically specified our DigitalOcean token in this secret. I have not created the manifest. Maybe I should have, but yeah, I have not created it because I don't want to basically push it to my GitHub repo. That is the reason I have not created the manifest. But this is the secret that has one value with key access-token. Or let me try to show this to you. So kubectl get secret du-token -o YAML, and this is the secret that I just created, and maybe I'm going to push this as well. I will change it later. Okay, so once we have the secret created, or once we have the secret manifest, we are going to use this particular key as environment variable into this particular application. So we are going to name it du_token, and the value is going to be from that secret, and we can specify that value using value from keyword here, and value is going to be secret key reference, and secret key reference takes name and name of the secret, and key is going to be which particular key from that secret. So if you look into secret, name of the secret is du-token, and the key is going to be access-token. So once we have set an environment variable called du-token, now we can pass the argument like we are passing hyphen endpoint. Similarly, we can pass hyphen token as well, and hyphen token equals to dollar and the environment variable, and this is the environment variable. So now let's go ahead and try to deploy this entire thing once again, but obviously after building it. So I have built the binary. Let's go ahead and try to build the Docker image, and once Docker image is built, we are going to push it, and we are also going to change the image that we have specified here. And if you see here, it has been pushed successfully. So let's go ahead and try to apply everything once again. So apply -f manifests, and it should create this pod again, and we are going to look into the logs of that pod. Okay, so it looks like the PVC was already there. So we are going to delete that. We are going to delete that PVC, and then we are going to I'm also going to log into my DigitalOcean to show you that volume is actually being created. So while I'm doing that, I think we were able to see some errors here. So it says cannot patch resources events in API group. So this particular service account that is being used by CSI plugin doesn't have access to patch events resources. So we are going to give that permission. So if you look into the volumes, we don't have any volume here. And now if we look into these, if we look into these issues, it also says that it's not able to patch events resources. So let's go ahead and try to give that permission as well. So if you see here cannot create events resources, so we basically have to give two permissions, patch and create on events. Patch and create. Now you can obviously make it better. For example, if you don't want to give create on these two resources, you can have another list here, and you can specify. You can obviously give granular permissions, but yeah, I think you understand that. Now let's go ahead and try to apply everything once again, just to make sure that controller actually has updated permissions. And now we are going to create the PVC, and let's see what exactly happens. So it says create volume was called. It also prints all these details somewhere. Okay, it says provisioning failed to provision volume with storage class bsos. Okay, so it looks like something is breaking, but we are not able to logging the error message correctly somehow. So yeah, just a second. Okay, so I think this is the log uh, from create volume when we print volume request. Okay, so I think this is the problem. So what we will have to do is we will have to do something like this, or what we can do is just to make sure, we can actually have another another const here. Const, let's say we are calling it gb equals to this, and then we are actually going to divide it by gb. Let's go ahead and try to build it and deploy again, and let's see what happens. Failed provisioning the volume, we are not actually logging the error here. So failed provisioning the volume, and the error is this. Let's go ahead and try to deploy it again. I'm assuming that this was the problem, but let's see. So let's delete the PVC first, and I'm going to build the application again, build the Docker file, and then push that Docker file, and then change the image to newly created image, and then apply everything. So everything from this manifest directory is going to get applied, and we should get the new pod up and running. And let's go ahead and try to look into the logs, and let's create the PVC once again and see what happens. So if you see here, now it says successfully provisioned volume, and it looks like the volume has been provisioned successfully. So initially in the last request, if I try to show you, when the request was actually printed, we were not successfully able to convert kilobytes or bytes, sorry, to actually GB. So that is the reason we had the problem here. And in this particular scenario, if you see, we were successfully able to convert these bytes to 8 gigs that we have specified in the PVC. That is the reason volume was provisioned successfully. Now let's go ahead and try to look into the PVC. So if you see here, we have PVC and the status is bound. It simply means that the volume was provisioned. And if we get PV, we can see the PV as well. We can obviously see storage class. So now we are actually able to, if you see, we are actually able to provision a volume using the new CSI plugin that we have specified, and we are specifying that CSI plugin in the storage class that we have just created. Now our work is not actually done yet. So if you remember, in the in one of the previous videos, we have talked about it in a lot more detail. So when we try to create a volume, so the volume has just been provisioned in the storage provider, but that volume cannot be used by a workload, because that volume is not even attached to any of the nodes. And those are the other things that we will have to do in order to make sure that the volume is being consumed by the workload. So if we just go ahead and try to create a workload that uses that PVC, we would see that the workload is not coming up. And the reason is, again, because the volume is just created somewhere, but the volume is not actually mounted into the node. And if we refresh here, obviously we would see a volume created in here. And it also says that attached to a droplet. It simply means that this volume is not actually attached to any of the droplets. So what I was planning to show you is, so create a pod with persistent volume claim. I want to specify persistent volume claim name instead of actually Yeah, so this is how we can specify persistent volume claim. So vim pod.yaml, and we are going to save it, and let's move these two manifests that we have, pod and pvc, to tests maybe. So cd manifests mkdir tests and mv // pod pvc to here. Okay, so now if you see here, we have a pvc that is actually bound to a volume, and let's go ahead and specify that PVC in the spot that we are trying to run. So we are going to specify, we are not going to change anything, we are just going to change the claim name. The claim name is test volume, as you see here, and we should expect that test volume, or the volume that is being referred by this particular persistent volume claim, should be mounted at this particular path in this Nginx server that we are trying to run. Let's go ahead and try to create this pod. So kubectl create -f manifests pod.yaml, and let's look into why this particular pod is not actually coming to running state, why it's still pending in container creating state. So kubectl describe pod and task pv pod, and if we look into the events here, we are successfully seeing that the pod has been assigned to a particular node, and we should see in some time why this particular pod is not coming into running state, because the volume that we have specified, that volume will not actually be mounted in this workload, because like I said, the volume is created somewhere, that volume is not even mounted or attached into the node. So kubectl describe pod once again. Okay, it's taking some time, uh, but that is what would happen. I'm going to pause the video for a second to show that to you. Alright, so if we try to describe the pod once again, so describe pod task pv pod, and if you look at the events once again, the first event is obviously by default scheduler. It says that the pod has been assigned to a node, but attached the task controller here, if you say tries to actually attach that volume, but it is failing for this particular volume, and it is obviously timing out, because we know that that volume cannot be mounted in the workload, because that volume is not even attached to any of the Kubernetes nodes. So, and yeah, this is the thing that we are going to cover in the next video. Maybe we would be able to actually successfully run this pod that we have here. I think this is what I wanted to talk about in this particular video. If you liked this video, if you think this is going to be helpful to your colleagues, classmates, share it with them. If you liked the videos, like them, like button, and yeah, thank you for watching. I will see you in the next one. Thanks so much.